Okay, so remember, Venn diagrams look something like this. There's two different ways where they could look. They could look like this, being the juniors. Seniors. We could call them like A, B. And I separated them because there's no students that are going to be a junior and a senior. Let's just say traditional students wouldn't be a junior and a senior. These are called mutually exclusive. They don't have anything in common. And there's 149 juniors and 153 seniors. And so you might put the numbers right inside to show set A has 149 people, set B has 153 people, something like that. Another way, and the way we're probably used to using Venn diagrams, is where you have an overlap of set A and set B. That might be students in AP Stats and students who are juniors. Let's see, there is, like I put above, 149 juniors. Well, let me put it off to the side. We have 20 students in stats. And juniors who take stats. There are 4, I believe, 4 students that are juniors that take statistics. So I start with 4 students that are both. Now be careful, because the circle for A has to have 20 statistics students. So I already have 4 in the section that overlaps, so I only need 16. There are 16 students that are only in stats, 4 of which, 4 others are also juniors, making 20 altogether in that circle. So that means for juniors, I wouldn't put 149, I would want to put 145. So that in that circle, there's 149 people, trying to take into account the 4 people that overlap. Then there's a couple notations. So the complement. Let's see the complement of A. That would be everything not in A. So, for example, if we want to do the complement of A, that would mean, I'm going to do another little sketch over here so that I don't massacre my other drawing. Everything not in A, so that means only this section of B, and actually everything else that's not even included. Sometimes there's numbers that are not included in either A or B, and we put them outside, those numbers would count as well. And the way we're going to denote it is we're going to say A complement. So to calculate A complement, we would want to eliminate all 20 students in AP Statistics in those 4 juniors that are in both AP Statistics and juniors. So it would only be those 145 juniors that are not taking AP Statistics that would count. The complement of B would be everything, again I can do another, this is an example of A complement. B complement would be everything, you want to count everything that's not in B. So that would be the 16 students that are in AP statistics that are not juniors. No juniors can be counted for that one. And ironically, what should end up happening, there is a lot of probability rules, and instead of just memorizing the probability rules, I want to how they actually develop. So there is the complement rule. And I guess to find the probability of a complement, you could actually find out what's in A. There's 20 items in A, and take it away from 1. And notice I'm doing probability. So the probability of picking a complement of A would mean that I would be picking, I have 145 choices out of a total of, we got to count up how many are in this as well. There's 165, I believe, in this whole thing. And that would be the same as 1 minus all of the items that are in A. There are 20 items in A, 20 people out of 165. And if you do that math, you'll get 145 out of 165. And it checks. So that works with probability. The probability getting everything is 1. And so taking away everything that's in A would leave you with everything that's not in A. And that's basically what a complement is. Let's see. The other thing I wanted to talk about was A intersecting with B. And in other words, it would be A and B. So if you look up there, what's in A and in B of this Venn diagram that's not mutually exclusive, the second one. What's in A and B would be where they overlap. So there are 4 students in A and B. That works for both. Now if we look at the top one, the mutually exclusive one, A and B, there's nothing that they have, no students that overlap. That's why we didn't actually overlap them. Another rule, and let's talk about this for a second, is A united with B. We call it a union, A-U-B. And this means A or B. So I'm going to go up to the top one first before I discuss this one, A union with B. That would be, it can be in A or it can be in B. How many students is it? It would be the total. You would want to add all the students from A and all the students from B to combine them. I think it's like 302 students that are combined. It'd be like saying how many are juniors or seniors in the whole school. There's 302 people that fit that mold. When I come down here and I say how many students are in AP statistics or are juniors, and you just got to be careful that you don't count these 4 students in our class that are juniors and AP statistics members twice. So technically, I would only be taking the 16 stat students that are seniors, the 4 students that are both in statistics and juniors, and the other juniors, and combine to make 165 people. altogether. That's where I was actually getting the 165 from above. Now, it's kind of tricky when you think of it separately, though, and I'm going to load that on the next page. But for now, hopefully you're getting the idea that union would be everything in A, everything in B, and everything that they share. You just got to be careful you don't count that middle section twice. Okay, so an example. Let's say we have 20 stats students, and let's do seniors. There are 153 seniors in the school, and there are 16 enrolled seniors in AP Stats. Find the union. We can make AP Stats A and seniors B. How would you calculate the union? You can't just add up 20, 153, and 16, because there are 16 seniors that are being counted already here, and those same 16 students are being counted within here. So we have to be careful that we don't want to use them twice. We also don't want to eliminate them and forget them altogether. So if I were to build a Venn diagram that might help us, and then I'm going to give you a formula that's actually one of the probability rules too. Let's do, these are my AP Stats class students, and these are the seniors. Okay? So there's 16 enrolled in both. So far in that AP Stats class, I have 16 people in that circle. I only have 20 students total. So there are 4 students who are only in AP Statistics that are not seniors. Okay? And that's that complement idea. Not a senior would be the 4. Let's see, the seniors, there are 153 in the school, but you cannot use 153. You've already got 16 as part of that circle. So technically, we've got 137 students who are seniors that are not in AP Statistics. If we combine the students that are in statistics, then total would be 153 seniors. So finding the union, we would add up 4, 16, and 137. But now, let's take a minute, and I want you to think about it separately. Okay? You would actually be taking, let's say we took all of A, all 20 students, and we took all of B, 153 students. That would give us 163 students. But that's actually taking into account these 16 enrolled students that are both statistics and seniors. We've counted them in here, and we've counted them in here. So technically, we have to take away how many are enrolled in both. How many are in A and B? So you have to take away the 16 that are in both. Technically, to unite the seniors and my statistics class together would only be about one. That's why it's not working, because I should make that 173. To combine those two makes 173, and then take away 16 would be 157. Total students who are in AP Statistics combined with the amount that are seniors or seniors. And this is called the addition rule.